Quinoa, scientifically known as Chenopodium quinoa, is a plant belonging to the Chenopodiaceae family. It is a functional food valued for its excellent nutritional properties. Quinoa is sometimes called a pseudo-cereal because it is not an actual grain, but is still well balanced in oil, protein, and fat content. It is also rich in vitamins, minerals, and antioxidants that can play an important role in reducing disease risk. Because quinoa can tolerate harsh environmental conditions, it is also an important source of food security. Quinoa is a genetically diverse plant that is closely related to beets and amaranth. Despite its variability, it is still acknowledged as a single species. In general, quinoa is a highly branched plant with a cylindrical stem and goosefoot-shaped leaves that vary in color. The roots can penetrate up to 1.5 meters beneath the surface, which is partly why it is so resilient in times of drought. Quinoa is also gynomonoecious, meaning it has hermaphrodite and female flowers that are both incomplete and lack petals. Its fruit is an achene that makes up multiple layers and has a variety of shapes. The round, flat seeds of this crop are likewise diverse. Because quinoa is such a stress-tolerant plant, it can be cultivated in many different habitats. Quinoa has been grown for thousands of years in the Andean region, where it originated. Through trade and transmission by livestock movement, it eventually spread to other parts of South America. With the arrival of the Spanish in the 16th century, the cultivation of quinoa continued only where natural physical barriers prevented the introduction of new foreign crops. The resulting separation and isolation of quinoa production are largely responsible for the genetic differentiation of the plant. Recently, however, there has been a renewed interest in quinoa, which has led to its cultivation all over the world. Traditionally, quinoa was used to either complement or to replace animal protein. To remove saponin, they often dry polished and/or washed with a stone. After processing, whole seeds were usually used to make dishes such as soups, quispino, a type of quinoa bread, dacte, a type of fried quinoa cake, and besque, a salted quinoa porridge. There have been a few reported cases of its use for medicinal purposes. It is said to be effective in reducing inflammation, disinfecting the urinary tract, healing fractures, and treating internal hemorrhaging. Today, quinoa is eaten as a substitute for rice, made into porridge and infant food, or ground to make flour. It can also be used to make beer by a fermentation process. Another beneficial aspect of quinoa is that because it is gluten-free, most people with celiac disease can safely consume it. The high nutritional value of quinoa can largely be attributed to its exceptional quality of protein content, which averages to a total of about 14.4%. Quinoa proteins have a wide, well-balanced range of amino acids, including many of the essential amino acids that can only be obtained through diet. Quinoa has around 72.6% of carbohydrate content, which have been shown to have hypoglycemic effects and can lower free fatty acid levels. Lipids comprise another 6% of quinoa. As seen in the table, quinoa is a relatively good source of the essential fatty acid omega-3 and omega-6. These and other fatty acids are well preserved in the crop because of the presence of vitamin E. Compared to other grain crops, quinoa has especially high concentrations of potassium, phosphorus, zinc, magnesium, iron, copper, and calcium. These levels, however, can vary depending on the soil type and cultivation techniques. Quinoa is also rich in vitamins. The vitamin C content, however, is usually present but is very vulnerable to oxidation. As previously stated, quinoa has an exceptional ability to adapt to various environmental stressors. This means that it has a heightened concentration of antioxidants, some of which include carotenoids, flavonoids, and 6 different flavonol glycosides. Many of these antioxidants are effective free radical scavengers. There have been several interesting in vivo studies concerning quinoa. One of these studies has found that the administration of quinoa seeds to rats that are under fructose-induced oxidative stress showed a protective effect against plasma peroxidation. In a separate in vivo study, it was shown that rats that were once again fed high fructose foods had lower blood glucose levels after the administration of quinoa seeds. While quinoa is abundant in its nutrients, it also has its anti-nutrient component, which includes saponins, phytic acid, and protease inhibitors. Although some of these compounds can be removed through processing, it may be at the cost of a slight alteration in other beneficial chemicals. Saponins are interesting compounds because they are toxic when ingested in large quantities, but from a pharmacological standpoint, they can also be beneficial in that they can increase the permeability of cell membranes. This can subsequently aid in better absorption of food and drugs. While quinoa is now cultivated all over the world, it is still mostly grown in South America. The demand for and the production of quinoa have dramatically increased over the past 2 decades because of people's growing attraction to the health benefits of this crop. In Bolivia, the cultivation of quinoa has especially intensified with escalating international market prices, which rose up to around $2,300 per ton in 2008. The export value is increasing as well, which was around $8.9 million in 2006. Unfortunately, the increase in production has put a severe strain on the environment as well as sustainable production. For example, natural vegetation is being destroyed in an attempt to expand agricultural lands, and the soil is becoming less and less fertile due to the overuse of tractors. This ecological degradation, in turn, has now triggered a domino effect in which it is becoming more and more difficult to grow this income-generating crop in the rural population. Quinoa, without a doubt, is an important source of food as well as food security because of its well-balanced nutritional content and resilience in harsh growing conditions. This clearly speaks for its abundance of allelochemicals as well as diverse health benefits. With the growing interest in recent years, it would not be surprising to see quinoa incorporated into many world cuisines. Hopefully, this trend will not only contribute to a better overall health for people that rely on overprocessed foods, but also provide food security and reduce the issue of malnutrition in communities suffering from food shortages. However, this would mean that there would be even more demand for quinoa, which makes it critical that a more sustainable approach to the production of this crop be taken into account. This will alleviate the current economic and environmental strain on the production centers, which will ultimately affect the chemical composition of quinoa and the resulting impact on human health.